Hi, my name is Frederick Lintz. I am the CEO of Exostiv Labs. Today I'd like to demonstrate how Exostiv Blade is capable of capturing FPGA data from multiple test sites and target boards with multiple users. I will use the following test setup. It is composed of two Exostiv Blade units connected to our company network. One of them is built in a compact tower form factor enclosure. Its network ID is Exostiv Server 001. The second one is a 2U chassis. Its network ID is Exostiv Blade 001. First, I'll show that a single user can run multiple sessions concurrently on multiple Exostiv Blade units. For this, I run captures from the two Exostiv Blade units connected to our company network. I will use two separate client sessions with the same login credentials. Second, I'll demonstrate the ability for separate users to access separate targets connected to the same Exostiv Blade unit. One Exostiv Blade is connected to two separate target boards using two separate QSFP28 connectors. Each board contains data generators that can be sampled, and the captures are collected through the board transceivers at 25 gigabit per second. Please note that 1 to 4 transceivers can be used in a single QSFP28 connection of the blade. Multiple such connections can be used for a single FPGA or more than one device. Finally, I will demonstrate how these sessions can be controlled from the provided Python API to ease control and task automation. I have started 3 Exostiv Blade client instances which I'll use to control the captures from each target. First, we need to load the settings for each client instance. The settings contain the characteristics of the IPs inserted into the target FPGAs and the characteristics of the connections to the attached Exostiv Blade unit. Once the project is loaded, a specific control interface is available in the client application. It features capture parameters, trigger controls, and waveform viewers to visualize the captured data. Now let's connect the client to a specific Exostiv Blade unit. This interface lets you scan the network to find the available Exostiv Blade units. Exostiv Blades are identified by a network ID and an IP address. You can read their status here. Each user needs to provide login credentials to log onto a blade and select the desired session. There is always an initial configuration done by an administrator which specifies what is connected on which port of an Exostiv Blade. In other words, a session designates a physical connection with an Exostiv Blade unit. Now, this client contains the settings and controls of the Exostiv IP available in the target FPGA and is connected to the corresponding session available from an Exostiv Blade unit on the network. The waveforms you see were previously captured with the same session. As you can see here, the client lets you define the memory allocation for each capture unit of the same IP. As you might know, each port of Exostiv Blade comes with memory storage for the captures, typically 16 GB per 100 gigabit per second port. I'll now connect a second session to the same Exostiv Blade and use other credentials. you can see that the status reports that the other session is used. So I select the other available session and connect to it. And finally, I connect the third Exostiv Blade client to a session of the second blade on the network. Done. There are two clients connected to Exostiv Blade 001 and the third client is connected to Exostiv Server 001. The two sessions visible on the screen use separate Exostiv Blade units, so the same or separate users can open any number of client sessions on any number of Exostiv Blades concurrently. We see that we can run captures from each client interface. Here we have run a capture from KU3P board and we are able to watch the resulting waves in the waveform viewer. Now this is a capture from the KU5P board. And again the capture data in the waveform window. Now this is a simultaneous capture from the two Exostiv Blade units. Being able to access multiple test sites in parallel tremendously augments your ability to run tests on FPGAs. The benefits are really countless. You don't have to globally duplicate FPGA debug and test equipment. You can share resources among multiple teams, and you can let them run FPGA board captures from anywhere, including home offices. Now I'll capture data from two separate FPGA boards connected to the same Exostiv Blade. Please remember that each session uses separate user credentials. This reduces to two users accessing separate board sessions with the same Exostiv Blade unit. I am changing the capture parameters and launching the captures. Here we can clearly see from the progress bars that the two sessions are capturing at the same time. The user can inspect results from a completed capture as another session is still running. And this no matter if the same or separate users control the sessions. The second session capture has ended. We can inspect the waveforms as well. This is now an example where we run all 3 sessions concurrently. I am reorganizing the windows and display the more compact multi-capture view of the clients. Here we go. See each session progress bar as we are running. So the 2 Exostiv blades are running 3 captures in total. All clients are running from the same machine. In the examples that we have shown here, the waves are stored locally on the Exostiv Blade units. It is also possible to move databases to network drives at will and inspect data locally. Various data encoding formats are available. In this last part, I briefly demonstrate the Exostiv Blade Python API. Here is an example of Python script that controls 2 sessions, pretty much like we have done using the Exostiv Blade client graphical application. This script logs into Exostiv Blade and opens 2 separate sessions. It selects a capture unit for each session, establishes a link for each board, and runs captures successively from each open session. There are 5 iterations.